Welcome to the JavaScript Tech Interview exercise number 5. In this exercise, we're gonna solve the Connect 4 puzzle. What is the Connect 4 puzzle? Let's see. Most likely you have played with it already. Connect 4 is a version of Gomoku where you have to get 4 of your signs horizontally, vertically, or diagonally from the same color. Now, in this exercise, we're gonna ignore the diagonal matches because it's just yet another computation. The exercise is as follows. Suppose an 8x6 Connect 4 table is given. Each cell of the table is either empty, which results in a null value, or contains the player's number from the possible values 1 and 2. So player 1 has the symbol 1 and player 2 has the symbol 2. Determine if any player has won the game by connecting 4 of their symbols horizontally or vertically. For simplicity, ignore diagonal matches. Let's get started with the solution. I'm gonna use the Chrome developer tools this time, and first we'll have to assemble an empty table. So let's create a createEmptyTable function. What we're gonna do is we'll create an array of length 8 and we're gonna fill it with null values. Let's test the solution. So far this is not rocket science. If we call the createEmptyTable function, we're gonna get an array of 8 nulls. Now we're gonna have to map each and every of these nulls into another array of length 6, and each of these arrays are gonna contain null values. So we do the same thing as before with a new array, 6 this time, and we're gonna fill the results with null. Let's test our solution by using console.table. So we're gonna write console.table createEmptyTable and call it as a function, and you can see the 8x6 board. This is an inverted table with respect to what the original game looks like, but it doesn't really matter. So let's create a table reference with the createEmptyTable function. You can see that the null values are still there. Let's now create a checkElements function. CheckElements is intended to observe an array and check if it contains 4 consecutive symbols of 1 or 2, which means that one of the players has won the game. I'm writing it in a comment just for you to see. So checkElements array checks if array contains 4 consecutive elements. Obviously these elements cannot be null. Let's provide the argument list of checkElements. Now we're gonna use some ES6 magic. If you're interested in more ES6 knowledge, go to my website joltnight.eu and sign up for my free ES6 newsletter. You're gonna understand every single construct I'm using here if you sign up for the free lessons. The first argument is an array. We can separate the head and the tail of the array with this construct, and we're going to be able to reference them inside the function body. We can add additional arguments and default values. Match count counts how many of the elements have been matched before, and the last element can also be memorized. So for instance, there were 2 1s in previous elements of the array that we have already checked. Then the match count is 2, and the last element is the symbol 1. We're gonna formulate a couple of if statements. So in our first condition, what happens if match count is 3 and the head of the array equals the last element? In this case, we have found 4 symbols that are the same, which means that checkElements has to return true. In the second if statement, if tail.length is 0, it means that we have finished checking the whole array and there are no elements left. We haven't found a match, so the result is false. The third if statement checks if the head is null. If the head is null, it means that no elements have been placed in the Connect 4 board. Therefore, we have to check the tail. Let's see the fourth if statement. If head equals the last element, it means that we have found a partial match, and in this case we have to return the checkElements call on the tail. We increase the match count by 1, and we keep the last element the same as before, which is either head or last element. It doesn't really matter. And after all these 4 if statements, we have to realize that there is absolutely nothing else left than just calling check elements on tail, starting a new match with the head value or the head symbol. Notice that by the time we reach this statement, we know that head is either 1 or 2, and the previous value was not the same as the current value. And we also know that there are elements left. So the check elements call with these arguments is legitimate. Let's test our function. We can provide 4 ones in an array to check elements, and we can see that the result is true as expected. Let's add the null in between. In this case, check elements is false. And as a final check, let's add some more elements and the match. We can see that the result is true. And if we invalidate the match, then the result becomes false. Check elements seems to be working perfectly. But you know what? I'm not too satisfied with this check elements function because there is a lot easier way to assemble the exact same function. So let's clear the console and let's display check elements once more just to see how much code we've already written. We're going to solve the exact same exercise, writing the exact same function by using a simple regular expression. By the way, if you're interested in learning regular expressions in JavaScript, I have quite a few articles on joltnight.eu. We can capitalize on the idea that the toString value of an array is nothing else but the concatenation of the values of the array separated by commas. We don't even have to know that the toString value of a null inside an array is an empty string, because whatever that value is, it's definitely not going to be 1 and 2. What we're going to look for in the regular expression is either the character 1 or the character 2. What we are looking for is this character, then a comma, then the same character, then another comma, then the same character, another comma, and the same character once more. How can we repeat the character that we chose? Well, not by adding the character set, because then it would not matter whether the second character, the third and the fourth are 1 or a 2. But what we're gonna do is we're gonna capture the value of the first character by adding some parentheses around the character set, and then reference the captured character by using \1. This is a regular expression specialty. With \1, we can reference whatever was matched inside the first parentheses. And that's it. This is our solution. We solved the same problem in 1 line of code. Let's test the results once more. I'm gonna create a new array. You can also check there are 2 string values, which is comma separated, and instead of the null there is an empty string, obviously. And check elements is gonna find the pattern 1, 1, 1, 1, so the result is true. Let's pop the last value from the array. We expect a false result, and as you can see, the result is indeed false. Check elements is done, so now we can reuse this check elements function to check the columns and the rows of the table. Let's start with check columns. Check columns is a function that expects a table and returns a reduced value of the table. Now, table is a multidimensional array, and we have to check each and every array inside this array whether there is a match inside. Reduce expects 2 arguments, a function which transforms a previous aggregated value, which is in our case hasMatch, and the current array value, which is in our case column, to a new value which we're gonna pass to the next function call in the reduction. And the return value of this function is hasMatch or check elements column. This means that if there was a match, the result is gonna be true, and if the hasMatch value was false, then the result is determined by the check elements call. We also have to initialize the reduction with a false value. Just for the sake of simplicity, let's add the console log as well, so that we can follow what's going on inside the reduction. This may make it easier for you to understand what's going on. If we execute check columns on the completely null table, you can see that the reduction results in false. So let's make a change in the table. We're gonna evaluate the 5th row of the table. In fact, this is the 6th row, but with index 5, to a value that contains 4 ones. And after the check columns call, you can see that up until this row that was just inserted, the reduction value was false, and afterwards the reduction value turns to true. And obviously the return value of the check columns function is also true for this reason. We don't need these console logs anymore, so let's remove it. Whenever you're in an interview situation, it's always allowed to log things to the console, always test your results, and always think in small increments. Otherwise, if you start writing big functions, then the whole thing is not gonna work, because sooner or later you're gonna make a mistake. And even if you don't make a mistake, more intelligent interviewers are gonna realize that you're basically jeopardizing your whole interview process by writing too much untested code. So check columns is done. Let's continue with the check rows function. In check rows, we have to extract one value from each and every column. How can we do that? Well, if you don't have a better idea, it's always safe to get back to the basics and use a simple for loop. This will always work. In the condition of the for loop, given that each and every column has the same height, we can just use table 0.length, because whatever index we use inside table, it's gonna be the same, it's gonna be 6. It's not even a problem if you hard code it to 6. In order to get the row array, we have to map the table and get the ith element of each column. I comes from the for loop. If we call the check elements function on the row array and we get a true, then we can just return it and exit the for loop right away, because we have found a complete match of 4 symbols completely connected. On the other hand, if we exit the for loop without success, this means that we have failed to find any connected 4 elements, which means that we can return false. Let's add some elements which yield 4 connected ones in columns 4, 5, 6, and 7. And let's call the check rows function. As you can see, the result is true. Let's make our connected 4 values invalid by changing the corresponding value in column 7 to a 2. And as you can see, the check rows table becomes false, because there are no 4 connected symbols that can be matched. We have just one task left, which is the check table function. We have to call the check rows and the check columns functions together and place an OR in between them to check whether the table has 4 connected elements. Once more, we didn't really care about the diagonal matches. If someone showed me the same solution and the same thought process, I would 100% know that they would be able to complete the diagonal matches as well, so we will not worry about it. If you like this solution, hit the subscribe button and check out my blog on zsoltnai.eu, where you can find the same example in a written form as well. Take care.